co-location facilities. In this case, there are 3 co-location facilities, and it puts 3 routers into these locations where it connects those routers up to the exchange point so that it has the possibility of peering with all those colored clouds shown on the right side of the diagram. So if you look at this traditional peering model, what you have is CapEx for the router, you have OpEx for the co-location space, you have deployment and installation expenses, and you have to sign paperwork with each exchange point that you're building into. It could take weeks, it could take months before you establish a presence using the traditional model. The remote peering model, on the other hand, is where there is already a remote peering provider physically installed at those co-location sites already. So when you order a remote peering service, all the remote peering provider has to do is turn up the transport that extends the peering fabric all the way to your customer router, and voila, you're up and running. This is a fundamental change. This will get people up peering without the CapEx associated with the router. In the case of one of the companies I spoke with, they're saving $1.4 million by not having to buy routers to put at these co-location centers across Europe. They don't have to sign the contracts with all these co-location companies because they don't have equipment at these co-location companies. They're leveraging the fact that someone else has already done the painful job of building out and extending the network from the exchange point out to the customer router location. So that results in much lower paperwork and near instantaneous turn-up. In fact, I was talking with Mr. Davidson, who tells me that they're working on some things that will make it even faster than days, maybe into the minutes that things can be turned up. So what does it look like from the customer router? Well, the customer just has to have a router at some location, and what's delivered to his router looks like this. It could be a 10 gig port that has individual 1 gig VLANs that are directly connected up to the different peering fabrics anywhere in the world they happen to go. I also heard over breakfast this morning that some folks are even going all the way from Los Angeles all the way into Europe and doing this remote peering in that configuration. So it's kind of a unique model, and it seems to be working pretty effectively across Europe. In the US, one of the things that my employer is trying to do is the exact same type of thing, to build a massive remote peering infrastructure. So when I ask people, so why are you looking at this? What are the use cases for remote peering? This is a graph that seems to speak to most of them. If you're familiar with the peering versus transit graph, on the vertical axis you have the costs for traffic exchange in dollars per megabit per second. And on the x-axis you have the number of megabits per second of traffic exchanged. So that purple line there, I have it roughly as flat, but it's actually a little bit stepped. But that purple line represents the cost of internet transit. And the curved line at the top that says traditional peering is the cost of peering against that price of transit. Now, if you have a traditional infrastructure and a traditional peering infrastructure, and you build into an exchange point, but you only peer 1 megabit per second, and it costs you $11,000 per month to build into that exchange point, well, that 1 megabit per second is costing you $11,000. That's $11,000 per megabit per second. That's a pretty expensive peering method. But if you peer more and more traffic, the price goes down. You peer 11 megabits per second and it costs you $11,000 to do that. That's $1,000 per meg. If you peer 110 megabits per second and it costs you $11,000 to do so, now you're down to about $10 per meg. And you see the price per meg goes down until it asymptotically approaches a max or a minimum point where you have to then upgrade the infrastructure. Well, that's the traditional peering model. What happens if you remove the cost of routers from that equation? Well, the starting point goes down. What happens if you remove the cost of co-location? Well, the point goes down. So that's why you see that lower graph called remote peering, it ends up having the same type of shape, but it starts at a much lower point. So what that means is that the peering break-even point, where one is indifferent between buying transit or peering away that traffic for free, it happens much sooner. You see it much farther to the left. One company I spoke with said the peering break-even point for them with the traditional model was out about 8 gigabits per second. In other words, they needed to peer 8 gigabits per second away for free to cover the cost of building into that exchange point. But with the remote peering model, they had that break-even point at about 3 gigabits per second, beyond which peering was provably cheaper. So what does this actually enable then? Well, what folks tell me is that they can therefore be able to go into a whole bunch more exchange points. They can take their network infrastructure and expand using remote peering that one 10 gig circuit into potentially 9 or 10 exchange points, maybe across the US or maybe across Europe, and have all that delivered onto one port on their router. So what happens when more companies can go into more exchange points? Well, that means that the peering population gets bigger and more traffic is exchanged with the peering populations at all those exchange points for free. So the entire community is growing. That's why I say this is a pretty fundamental, important change in the ecosystem. I spoke with one cable company up in Canada, and I asked them about peering, and they said that they come down from Canada as low as Ashburn, Virginia, Seattle, and Chicago, but they don't go any further. And I said, well, why not? They said, well, the cost of building into these different exchange points elsewhere in the U.S. is too expensive. But with remote peering, they're able to go down to Los Angeles, and Los Angeles has a very strong regional Asian set of routes. So they can peer that traffic away for free in Los Angeles through remote peering, and do the same thing in Miami to get access to all those South American routes. Again, remote peering is enable people to peer who otherwise could not financially justify it. So that's why I say to you today that peering strategies are really all about the blend of transit with peering, with remote peering, with CDN services, and with full POP deployments. There's an optimal mesh of connectivity in there somewhere, and you as network architects need to figure out which ones make the most sense for you. What is the appropriate blend for you to use? This is another one that popped up. I'm going to make the claim here today, for the first time I think, that Internet peering improves security. And I'd be curious to hear, maybe after this session, whether you agree with me or disagree with me. So here's the logic that says that Internet peering improves security. If you look at the commodity Internet, is intermingled